Hi friends, good morning to everyone. We have discussed the recursive relationship in the last class. We have focused on how to devise the recursion. In recursion, we have discussed right two important things to be considered when we solve the problem. Can you recall what are the two important things to be considered when we solve a recursive application? Lakshmi, Aruna, Srinidhi,
So recursion condition and termination condition.
recurrence relation, or we can say as a recursive condition, and another one is the termination condition, when to terminate the recursion and when right we continue the recursion. So the two important things should be considered when we design the recurrence relationship. I hope you are seeing right the slide in this open book. We have seen right how to find the recurrence relation for the factorial evaluation. Factorial evaluation, the recurrence relationship is n factorial is equal to n into n minus 1 factorial when n is greater than or equal to 1, and n factorial, right, this becomes 1 when n becomes 0. So this is said to be the recursive call, and when n becomes 0, we need to terminate the recursion, that is said to be the termination condition. We have solved the recurrence relation using the substitution method. So using the equation 1, n factorial is equal to n into n minus 1 factorial, we have found the value of n minus 1 factorial, and it is substituted in the equation 1, and we find right the next value, right, n minus 2 factorial. After obtaining n minus 2 factorial, that is substituted here, then the recurrence relation is extended by substituting the value of n minus 3 factorial. Finally, right, to terminate the recursion, when n becomes 0, 0 factorial, this results in 1, that acts as the termination condition. So finally, right, we have the relationship n factorial is equal to 1 into 2 into 3 into etc. n minus 1 into n. This is the thing, right, that we have seen in the last class. We have also defined the function in C++ to find the value of factorial, right? That is using recursion. So return type int, function name is fact, function, right? Formal parameter is n. We have checked if n is 0, then return 1. So carefully convert the termination condition into a program. If n becomes 0, the value 1 is to be returned. Else, we need to call the recurrence relation or recursive function as n into fact of n minus 1. Else, return n into n minus 1. We have checked right how the function has been traced for n is equal to 5. So we have called right fact of 5, fact of 5 invoked a recursion fact of 4, fact of 4 invoked a recursion fact of 3, fact of 3 right invoked a recursion, then fact of 2, fact of 2 right in turn called another recursive call as fact of 1, then fact of 1 called another recursion fact of 0. When we call fact of 0, the actual parameter is 0. That stage, the function parameter n receives a value 0. When the formal parameter n becomes 0, the value to be returned is 1. So fact of 0 returns a value 1. Finally, right, we have the evaluation 5 into 4 into 3 into 2 into 1, so that the value 120 is returned. That is the value of 5 factorial. This is a thing, right, that we have explored in the last session. Have any queries in this trace?
No queries, sir.
Now we are going to test, right, this recursive program in C++, and then, right, we move on to, right, the subsequent topics, right. We need to go through these topics: scope and storage class, local variables, global variables, static local variables, and how a function can return a reference, right, logically. These are the topics, right, that we are going to see. Now let us test, right, the logic of a recursion with n factorial. I hope you are seeing this editor, Turbo C++. Is this visible? Is this visible? Are you seeing this editor?
Yes, sir.
Okay. N factorial using a recursion. So as usual, we need to write define the header file hash include iostream.h, then defining a main function int main return 0. We do define a function called, right, factorial. Factorial that we are going to define as a recursive one. So return type is int, function name is fact, actual parameter is something. Let the formal parameter be n, int n. What is n? N is the formal parameter. Please take the notes. N represents the formal parameter. What is a recurrence relation that we have seen? If n is equal to 0, then we need to return a value 1. So equation 2, the termination condition, is properly represented. When n becomes 0, we need to return a value 1. This can be done by writing if n is equal to 0, then return 1. Then else what we have to do? We need to define the recurrence relation, that is the recursive relationship. When n is greater than or equal to 1, then the value to be evaluated is n into n minus 1 factorial. So we need to use else return n into fact of this n minus 1. So writing this expression in the else part, else return n into fact of n minus 1, else return n into fact of n minus 1. The result is returned to the calling statement. So next, what we have to do? What are the missing parts in this program? Function is defined. What is the next stage? Inside the main function, what we have to do? No idea. Once the function is defined, what is the next step?
Calling the function, sir.
Calling the function. Very good. Before calling the function, we need to declare the function, right? Where we have to declare a function? Function prototype. Function prototype should be defined at which location?
Below header file, sir.
Below header file. Very good. That is one option. Here you can define, for example, int main, sorry, int fact function parameter. That is data type is enough, right? Many times we have discussed int fact int. This is enough. Otherwise, you can declare the same in the beginning of the main function section. I have already said that, right? There are two places where we can define the function prototype. right? So whenever the function prototype, right, does not involve void means you need to write explicitly define void in the function definition, and you need to define void in the function prototype also. For example, right, I tell you in short, suppose f is a function to be called here. Normally, right, assuming right the function f does not take any parameter and it will not return any value to the calling place. So by default, its return type is void. Now to make the declaration, here you need to define, right, just simply f. In this case, the compiler treats f is a function that is defined right somewhere in the sense that following the main function. The function prototype of f signifies a compiler that function f will not take any parameter, and the return type of the function right f is a void one. That is a interpretation. If you define right declare right the function prototype f here, whenever you like to call a function right f, that is a significance, you need to use the same statement, right? For example, here f of something. So compiler right simply thinks that f of right the parameter list is taken as the function call to the user defined function. So if you define f of something here, this is not interpreted as the function prototype. So that's what I say. In this case, you need to define this as void, right? Return type is void, void f. Here we can define right void f semicolon. In this case, right here, right void f. This is not necessary. So there are two places you can define the function prototype. One is right before the main function, right? That means after the header file section. Otherwise, at the beginning of the main function section, we can define. So now compiler right how it treats void f. This is taken as a function prototype. Following right just f, right? This is said to be a function call. So compiler recognizes that f is a function that is declared following the main function, and you are going to call the function right after somewhere. So after this function prototype, calling f of semicolon, right? This will not result in a compile time error. So keep in mind that there are two possible places where we can define the function prototype. Understand or not? Clear? Clear or not? Having queries?
Sir, can you explain that void one again?
Void, okay. Here, right, that's what I said. Just remove this, right? For example, int fact int. This is enough. Assuming the function f is defined here. In this case, to make right the prototype or function declaration, we need to provide like this. Let us compile the code. No errors are there. I have not yet saved the file. Don't worry. In this stage, right, what is f? F is a function definition. This is defined right before the main function section. In case if this is commented out, now right the function has not been called right inside the main function. That's what no compile time error is there. In case here if you are calling f of something, one error is raised. What is the error message? Error call to undefined function in function main. So compiler treats what is f. F is an undefined function. You should have already defined or informed to the compiler that f is a function that is defined right following the main function section. Otherwise, here the statement right comment should be removed. So removing this comment, Now no problem because following the header file section, that means before the main function section, we have informed the compiler that f is a function that does not take any parameter and it will not return any value to the calling fields. Understand or not? Say yes or no.
Yes, sir.
In this case, here by default return type is void. What I am coming to say, we can remove right this highlighted statement. I am deleting this. We can provide the declaration inside the main function itself. In such a case, whenever the function does not return a value, introduce void and we can make the same as a function prototype using the keyword void. Now have a look into right the compile status. Errors 0, right? Void f has been additionally added. Here void f is given. You ask right what is the purpose of this? In case if void is removed, here right removing the void, normally right to include f before the main function, here you need to declare the function prototype. Logical concept is there are two places where we can declare the function prototype, but only one place where it should be defined at any time. Before the main function, that's one place, or before the function is called, say at the beginning of the main function section. Now, in case if you think right, f of the semicolon, right, this is function declaration, and this is a function call, no problem. The user right can think like this. But in the first statement, right, f of semicolon, compiler right should be informed. But how the compiler thinks? Compiler thinks that the first one itself is a function call because we are not properly defined the function definition. We have used right void as the optional one. So in that case, that's what I said. Void f should be introduced. Here, void f should be introduced. Now F9, no compile time errors are reported. So understand clearly there are two possible places where we can declare the function prototype. Now tell me what are the two places? Make it fast. What are the two places where we can declare the function prototype? Yes,
After the header file, just
after
after
the
the
header, after the header file, then what is the second
function
place?
calls.
Inside the main function, that is at the beginning of the main function section. Okay. Now, right, let us remove this function calls. Remove this with respect to our problem. Finding the factorial using the recursion, right? So either you can provide int fact int before the main function section, or this can be deleted inside the main function section. You can define the same because the return type is int, no problem. Int function name parameter list that is of integer type. This is to be a function declaration. Understand clearly, right? They are many times used the word function declaration or said to be function prototype. Prototype that means a model, right? So function declaration, function a prototype, both are same. Function prototype. So int fact int right function prototype is declared. Then let us call a function. When we call a function, since the function is returning a value to the calling place, we need to ensure the proper left-hand side variable or the returned result can be processed in the cout statement. Cout less than 5 factorial is less than. What is the function called? Fact is actual parameter. What is the actual parameter to be passed? What is the actual parameter to be passed?
5, sir.
5. Now the actual parameter is passed by value mechanism because 5 is a numerical type. All right fundamental types are passed as passed by value mechanism. We have already explored what is passed by value and passed by reference. So using passed by value logic, 5 is the actual parameter. Actual parameter is 5. Formal parameter n receives a value of 5. First it checks if n is 0. If n is non-zero, so it returns n into factor of n minus 1. As we have traced right earlier, right here, passing n as 5, it calls factor of 4. Factor of 4 calls further factor of 3. Factor of 3 calls factor of 2. Factor of 2 further calls factor of 1. Factor of 1 further calls factor of 0. Factor of 0, right, simply terminates the recursion from further recursive calls. Then the complete evaluation is made. Finally, we have the expression 5 into 4 into 3 into 2 into 1, so that we have the result 120. Let us save the file cexx20, compiling the code F9, no errors. So understand, function declaration, this can be done in two different places. One inside the main function, another one before the main function. That means following the header file section. And when you define the recursion, ensure that proper termination condition is required and the proper recurrence relation or recursive relationship is required. In this case, let us run the program. Since we already traced the logic, right? I don't want to trace a logic again. So 5 factorial, right? As we traced earlier, the result 120 is obtained. Having any queries in this example?
No
Have any
queries.
queries? In case if you want to find out how many times the fact has been called, right? As we decided earlier, right? Checked. Fact of 4 first recursive call, fact of 3 second recursive call, fact of 2 third recursive call, fact of 1, right? Fourth recursive call, fact of 0, right? The fifth recursive call which terminates the recursion. So when n is equal to 5, it seems that 5 times the recursion has been called. To verify that, here you can use the cout statement. Cout, you can write this way: fact fact of n, right? You can access the value of n as it is n, opening bracket, then opening right, closing double quote. Fact of n is called less than endl. Now save the file, compile the code, no errors. Control F9. Have a look into this output. Sorry, 1 minute. Yeah, have a look into this outcome. First, what happened? Fact of 5 is called. Then fact of 4 is called. Then fact of 3 is called. Fact of 2 is called. Fact of 1 is called. Fact of 0 is called. So when n becomes 5, in the first recursive call, we can first call, right? Actual call, we can see the message fact of 5 is called. Then it seems that right 4, 3, 2, 1, 0. These are the subsequent recursive calls. Finally, right, the returned value is assigned to the direct replacement here. You just think of in cout statement, right? In cout less than 10 means, right? 10 will be printed. Cout less than, right? In double quotes 10, 10 is printed. Cout less than x, the value of x is printed. Same way, just think of fact of 5 is a function call. During the function call, 5 as the actual parameter is passed. After the recursive definition is over, execution is over, the value 120 is returned to the highlighted place. So if you write cout less than 120, 120 is output. Cout less than fact of 5 means fact of 5 as the function call processes something, returns a value to this highlighted place. So just think of the highlighted fact of 5 is replaced by 120. It seems that cout less than 120. So the function call returns a value and the value is directly processed in the cout statement. If not, what he can do means, right, he can write a statement like this. For example, int f is equal to fact of 4. Then he can write cout less than f less than p and dl. In this case, the returned value from the function called fact of 4 is assigned to the calling statement. So just imagine that fact of 4 receives a value 24. 4 factorial is 24. 24 is assigned to the left hand side variable f. Further, right, the value of f is processed in the next statement. So you can see the message right here. The returned value is for 20. Have any queries in this example?
No queries, sir.
Very good. Then coming to write our core concepts, we need to discuss, right? Some more topics in the function. Here, what are we going to discuss? Following this recursion, we need to discuss these concepts. Scope and storage class. In C language, you might have studied scope of a variable. Scope of a variable is where the variable is declared, where you can access the defined variable that defines the scope. Storage in the sense that, right, lifetime, right, longevity, how long you can access the value of a variable. What is a lifetime, right? A variable takes the corresponding value. You might have seen, right, different storage classes: auto, static, register, external. By default, right, automatic variables are the normal variables. We can define int x is equal to 10. That is same as auto int x is equal to 10. R2 int x is equal to 10. That means these are automatic variables. Same as, right, int x is equal to 10. So wherever, right, the variable x is declared, only within that scope the variable is accessible. For example, a function f is declared, defined here. Inside the function, if you declare int x is equal to 10, then having some statements. Another function say f2 is defined. Here declaring one variable int y is equal to 25. Only when you call a function, that stage only automatic variables are created and initialized. Unless you call a function, the function local variables or something will not get created. So when you call a function right f from a main function, suppose this is int main. Inside this, if you call a function f, what happens? The function call has been transferred to right to execute this function f. That stage the local variable x is created because x is defined right with respect to a function. You cannot access the local variable outside the scope of f. Inside the function f2, we cannot access a value x. If we access x, this results in error. Inside the function f, if you access y results in error because x and y are local variables to the functions, say f and f2. Only within the defined scope, or it's a scope, this opening curly brace and closing curly brace. Wherever right you want to access within this opening and closing curly braces, the local variables right x and y are accessible. Outside the scope right, since these are local variables, this cannot be accessible. As far as storage class is concerned, how long a variable retains its value? When you call a function f, right, for example, initially x is set to 10. Now, if you don't want to modify the value of x here, so wherever right you want to access the value of x within this opening and closing curly brace, the variable x holds the value 10. When the control comes out of a function f, printing the local variable x will not retain its value, say 10. That is the concept of lifetime. Lifetime, right, in the sense that how long a variable retains its value. So auto static, right, register extern, right, with respect to files, right, we explore later. Uh, register, right, register variables to access faster execution. Then static, right, the to retain the values of variables, right, during the function call. In case if you define a function for int I is equal to 0, I less than 10, I plus plus. If you want to print a value of I, the value of I is printed like 0, 1, 2, 3, etc. 9. So every stage right the local variable I is incremented by 1 based on the condition the value of variable right I is going to be current value of variable I is printed. In case if we define a function like this g, here static variable is introduced. Static int h is equal to 0. Now initially printing the value of cout h means the value h is initially 0. Then having h plus plus, h will be incremented by 1, h becomes 1. In the second call of g, since h is defined as static variable, last value of h is remembered. That means the last value of h is taken because of the nature of h as a static variable. Since finally h is incremented by 1, second, third, fourth, etc. or subsequent initialization inside the function is not permitted. So second stage, right, if you print the value of h after this declaration statement, h is printing a value 1, then h plus plus h becomes 2. In the next call of a function g, right, the value, last value of h, right, say a 2 is taken, then a 2 becomes 3, 3 is taken, 3 becomes 4, 4 is taken. So static variables just retains the value during the function calls. Here we can take right static variables are local or static local variables. Likewise, right, you can have right some global variables. The global variables are defined right before the main function section. Once you define the global variable, The global variable can be accessible anywhere within the function definition. For example, int main. Here I am defining a global variable. For example, int strength is equal to say 20. str right as integer variable which is initialized the value 20. Global initialization is permitted. Inside the main function I can access a value of str right accesses the value 20. Inside the function f I can access str. Then inside the function f2 we can access the value of str. Wherever right we want to access the value of the global variable that is permitted in C and C++. So understand the concept of local variables. Local variables can have the scope. For example, X can have the scope only with respect to the defined function. Where can we define a local variable? That is the next question. Where can we define the local variables? What are the places, right, or where we can define the local variables?
Inside function, sir.
Inside functions, very good. The inside functions, that's all. That means, right,
Inside main
inside,
also.
right, the user defined function. Yeah, inside main. That's what I am coming to say. Main is also a function, right? Inside function, right, that we mean the user defined function. Other than that, inside the function again, right, you can also nest the scope. For example, here, uh, hatch is a function defined here. Now this is the opening and closing curly brace scope of fetch. Inside this you can nest right the local scope any number of times. Opening and closing, opening and closing, opening and closing like this. You can have any number of nested inner scopes. Here right if you define one variable a into a, you can access the variable right anywhere within this opening and closing curly brace. But here inside this, if you define same local variable r into x, r into h, r into y, the variable y is accessible only within this local scope. But since a can have the scope within this opening and closing curly brace, a can be accessible anywhere within the inner scopes. But the inner scope variables cannot be accessible outside the scope of inner scope. That is a logic. That is a logic of local variables. So once the global variables are defined, the global variables can be accessible anywhere. For example, inside the function h, assuming rate str20 is accessible. Now, inside the block or inside the function h, you can have any number of nested scopes. Wherever right you are in the nested scope, if you print the value of str prints the value 20. There is no doubt in that because str is a global variable. Global variables can be accessible anywhere right within the function definition or anywhere within the program. Now right let us illustrate right the global variables, and I tell you right one important operator, this one scope resolution operator. Double colon, right? This should be right put continuously. First colon, then second colon, double colon. This acts as a scope resolution operator. The scope resolution operator that is used to resolve the access scope that can have different purposes, right? One important purpose here is to access a global variable, right? When the local variable hides the global variable. Coming to the code, right? Directly, right? You will understand. Consider this example. Let us go for the next example. Introducing the global variables. Global variables. hash include iostream.h. I am defining the variable, say int strength, for example, s is equal to 20. Then int main having the statement return 0, assuming some functions are there here, say f1 cout less s less endl. Then second function f2 cout less is less endl. Assuming the functions f1 and f2 are defined. So here in this case, there is no need to define void f1 because function prototypes are given right before the main function section. In case if you want to give the function prototype inside the function definition, there you need to follow the strict type, return type, function name, data type of parameter list. Here you can define the variable, right? For example, I can define or simply write, I can define the variable cout s is equal to listen yes return 0. In this example, we have declared one global variable s. S is acting as a global variable. The global variable can be accessible anywhere within the program. Have a look into this outcome. Control F9. What happened? One slash okay, F2 F9. Control F9. S is 20. The variable S is accessible inside the main function. We have not called F1 and F2. Let us call F1, F2. So calling F1 and F2, we are accessing the global variable S. I has been saved. Control F9. So second and the third line outputs a value 20 corresponding to the function calls, right? F1 and F2. So what is S? S is a global variable. Global variable can be accessible anywhere within the program. That means even right inside the main function section or even inside the user defined function section. This is one logic. Here, in case if you want to define one local variable, have a look into right the changes that we are going to make in the function f1. Cout s, what happens? The value of s is printed as 20. I am updating a value of s here. Int s is equal to 25. In this case, cout less s less or s inside f1. Can you predict the value of the statement? What is the value of s inside the
25.
function? 25. Because inside the function f1, this s is taken as a local variable. Have a look into this outcome. I already said that right just a few minutes back. Some variables are declared inside the function. Memory is created or the variables are right allocated the memory only when the function is called. So before calling the function f1, the local variable s is not created because you are not yet called the function f1. Only at the time of calling the function f1, what happened? The function f1, function statements are executed in the sequential order. Of course, first statement prints the value of s. that s is taken as a global variable, then int s is equal to 25, one local variable is created. So hereafter, right, if you print the value of s, the local variable is printed, right? So s inside f1, this results in a 25. You can also nest the scope, right? For example, here within this opening and closing curly brace, see out s is printed. Then I define, right, another scope here, int s is equal to say 75. We are printing the value of s. Before that, right, I show you see out s inside local scope of function f1 less than s less than e and dl. Then int s is equal to 75. We are printing the value of s. The value of s after s is equal to 75 less than s less than e and dl. The block has already been created. This is the opening curly brace and this is the closing curly brace. Now have a look into the outcome. No compile time errors. I have run the code. Initially, right, yes, inside the function f1, right, that is this 25, no problem. Then yes, inside the local scope of f1, what happens? Here the value 25, this 25 is accessible anywhere within this opening and closing curly brace. So here, right, if you print the value of s, this is not pointing the global variable yes. Instead, the local variable, right, a 25 is taken. Again, yes, inside the local scope of function f1 is 25. Then a new or local variable s is created, but this is created in the same name. So here, if you print the value of s, this s hides the yes, right, that has already been created outside this local scope. Outside this local scope, yes. Outside this local scope, already the variable s is created. That is hidden inside this local scope. So s is equal to 75. Hereafter, wherever you want to access a value of s, the value 25 is printed. So after s is equal to 75, the value of s is taken as, sorry, 75. The value of s is taken as 75 because a new local variable s is created with the same name. In that stage, right, the local variable, right, hides, new local variable hides the outer variable that has already been created. In this case, right, if you want to access the value, right, global is less than scope resolution operator is less than e and dn. Now compile time errors in this case, printing the value of, right, global yes, right, what is global is that we have said yes, global is has been set as 20. We are accessing the global yes, right, even inside the local scope of a function. This is actual scope of a function. This is said to be the nested scope of a function. Like this, within this highlighted block, you can define any number of nested blocks, right? So nested blocks are defined with respect to opening and closing curly braces. We can define, for example, here after this, right, we can have some statements. Then inside this, we can have some statements. Then inside this, we can have some statements. These are perfectly valid The only thing is you need to ensure the number of opening curly braces that should be equal to the number of closing curly braces. So each opening and closing curly brace defines a block of code or scope of the function, right? Likewise here, this is the local scope, opening and closing curly brace. This nests another local scope, so this is to be a nested local scope. This is another nested local scope, right? This is another nested local scope, right? This is the local or function scope. The function scope nests, right? That means cascades, right? Several local scopes inside that. So wherever you want to access the global variable, you need to use the scope resolution operator. For example, cout, listen, inner, right? Some inner scope. Here we do want to print the value of scope resolution operator, double colon, yes, listen, endl, semicolon. File has been compiled successfully. Control F9. You can find the output in the inner, right? Some inner local scope or in the innermost local scope, whatever it is or wherever is, right? Now to access a global variable, only one thing, the scope resolution operator is introduced. Scope resolution operator is defined using this symbol, right? Double colon, yes, double colon, yes. So simply accesses the value of the global variable. Understand or not? So whenever, right, you have some local variables, when the local variable or local variable hides the global variable, to actually access the value of a global variable, we need to introduce the concept of a scope resolution operator. The scope resolution operator resolves the name collision so that the global variable's value is accessible at the time of using the scope resolution operator. So keep in mind that variables can be local or global, right? Variables can be local or global. Local variables are, right, created or defined only with respect to the scope of function. That may be, right, inside the user defined function, or you can define it inside the main function. So wherever is inside the user defined function or inside the main function, we can create a local scope. And you can define a global scope, right, that is possible only with respect to this declaration. Global variables should be defined before the main function section. For example, data type variable name is equal to value. This is taken as a global variable. Wherever you want, right, you can access the value of a global variable, right? That is a logic. And to access the global variable, right, when the local variable uh, matches, right, the value of when the local variable matches the name of a global variable, there, right, name collision will occur. So the local variable hides a global variable. That case, to access the actual value of a global variable, the scope resolution operator is introduced. Have any queries?
No, sir.
Good. So far, right, we have seen, right, these things: scope and storage class, local variables, global variables, right, static local variables. One thing, right, we need to, right, explore, that is returning by reference, right? How a function can return a reference to the calling place. Normally, a function, right, returns a maximum one value to the calling place, as we have seen, right, in the factorial example, right? Or seeing the main function return 0, only one value is going to be returned to the calling field. In case, right, if you define the return type as a structure type, the function can return the local structure as a return value. Since structure is the heterogeneous data type which consists of more than one data types or more than one elements in it, when you define the structure variable, the structure variable points all the members of structure elements, right? So using structure variable, the corresponding structure members, more than one elements can be accessible. Logically, if you return the structure variable to the calling place, how many number of elements are there in that structure, that many number of values. That means the complete structure is returned to the calling place, which means that through structure we can return multiple values to the calling place, right? That is possible in C and C++ because C++ also right supports the concept of right structures within the same compiler. You can also define the structure right inside the C++ program, can create a local structure, assuming that the structure can have right multiple elements. When the structure is when the function is returning the entire structure to the calling place, how many number of elements are there in that structure, that many values are returned to the calling place, so that you can process the return values using again the name of the structure, right? Sorry, structure variable dot, right? The corresponding element in the structure. Another strange concept in C++ is this one, returning by reference, right? This is a strange concept. So far, we have seen that a function returns right a maximum one value to the calling place. Returning by reference in the sense that in the function definition, we will use a statement. For example, uh, return x, right? A return y, or we can use some uh, variables, right? The variables, right, which are declared as global variables, and the global variable name is right mentioned in the return statement. Return x, return y, return z, assuming that x, y, z are the global variables. So just to think of, normally, right, if you return right some variable, the value of variable is returned to the calling field. There, the function call is right processed in the cout statement, or function call is processed in the assignment statement, as we have seen in the previous example in the factorial computation. Directly you can call fact of 5, or some into y is equal to fact of 4. There fact of 4, fact of 5 function calls. Simply write in the function calls with respect to the assignment statements. Function calls are placed in the right hand side of is equal to operator. As we have seen, int x is equal to int y is equal to fact of 4. Y is equal to fact of 4. After the assignment statement fact of 4, the function call is placed. But using returning by references, we have a strange concept that function call should be made in the left hand side of assignment statement. So that's what I say. This is a strange statement. Suppose we will write a statement like this: F this is equal to F this is equal to 10 semicolon. Assuming that F is a function defined, the calling statement is F is equal to 10. It's a strange statement. Function call is placed automatically before the is equal to. That means the left hand side of is equal to. In this stage, the function returns some variable references, say x variable, y variable, z variable, or simply some variable. That variables references are returned to the calling place, so that in the left hand side, what is actually right processed means reference variable is processed. X is equal to 10, y is equal to 10. So indirectly, right, the statement results in some reference variable or global variable, right? Say global x is equal to 10. Assuming that x is a global variable, right? So global variables reference can be returned from the function definition. That is the logic of returning by references, right? We will explore it again, returning by reference, right, in the next session. If you have any queries, you can ask now. Have any queries?
No, sir.
I posted the materials, right, along with the source code, right, after some time. Please go through it, and if you find, right, any doubts, right, you try to post it in the GCR. Okay, thank you very much.
Thank you, sir.
Thank you, sir.